Alright, welcome to another episode of Como's Geometry with me, Como, and nobody else, because I'm talking to myself. Please feel free to keep count of how many times I sniff during this video, as I can't control it. Let me know how many times it is, so I can tell you I don't care. Alright, this is the proof of the Pythagorean theorem. Lots of questions on the next test about the Pythagorean theorem. Let's jump right in. So given this triangle, we're trying to prove a squared plus b squared equals c squared. A squared plus b squared equals c squared. Here we go. First thing we want to do is draw the altitude of the triangle. The altitude is the one line perpendicular to a side that goes through the opposite vertex. The altitude must be the altitude from the hypotenuse. That's hypotenuse, not hypothesis, to the right angle. It's very important. We want that altitude, which is also 90 degrees because the altitude definition is perpendicular. So we're able to do this due to our constructions. Number 3, xwy. This is to be labeled W, says it right there. xwy, this triangle, and ywz, this triangle, are right triangles. That is due to the definition of an altitude. The altitude is perpendicular, which is why I was able to draw this box. Therefore, both of those triangles are perpendicular, which makes them right triangles. xwy is similar to ywz, or xwy is similar to xyz. xyz is a right triangle. xwy is also a right triangle. So both of those triangles have right angles. And notice this small triangle up here and the large triangle both share angle x. So the two triangles are similar. Angle, angle, similarity. They both have right angles. They both share this one angle x. xwz, or ywz, this triangle here, is similar to xyz. They both have right angles. And they both share this angle, angle z. Angle, angle, similarity. Then you have this triangle, similar to this triangle, and this triangle similar to the same triangle. So if A is similar to B and C is similar to B, then these two triangles also have to be similar. And that's the transitive property. Similar shapes have proportional sides. This proportion is very important. I'm going to draw right here my three triangles. There's the large one, x, y, z. Here's the second one. The right angle is on W. This is the short side, so this is y, and that would be z. And then the small one, again, the right angle is at W, the short side's x, so this would be y. Now we've set up proportions. Back on our triangle, I'm going to label xwp and wzq. So xw, this piece here, let me get a different color. xw is going to be p. yx is a. zy is b. zw, this side, is q. And then xz is c, xy is a, and yz is b. Now remember, we're trying to get the Pythagorean theorem, which says a squared plus b squared equals c squared. So we're trying to get a squared plus b squared equals c squared. When we have proportions, the only way to get numbers squared is to multiply the same. The only way to get letters squared, sorry, is to multiply the same letter by itself. So when you set up your proportions, when you cross multiply, you want to multiply the same letter by itself. So a times a squared. P times c, we're not going to worry about that quite yet, but it's cp. B times b is b squared. Q times c is qc. We set up the proportions. Let's erase that. Properties of similar triangles. That's where my proportions came from. Corresponding parts. A over p, this is the hypotenuse over the short side, equals the hypotenuse over the short side of the big triangle. Q is the long leg over the hypotenuse. So this has to be long leg over the hypotenuse. This should be a B. When you cross multiply, that is the cross product. Now you have a squared and b squared in your proof. To get these two separate equations into one, we're going to add them together. I'm going to add b squared to both sides. I added b squared to both sides of this equation, which is the addition property of equality. You can add the same thing to any side as long as you do the exact same thing. Then this is exactly what I want, so I'm not going to touch it. I have to change the b squared. What do you know b squared is? QC. So substitution. I'm going to substitute QC in for b squared. Now both of these terms have a c, so I'm going to factor that c out, which is distribution property, and you're left with c times p plus q. If you look back up here at your picture, if you add p and q together, p plus q is c, which is the segment addition postulate. And then c times c is c squared, which is simplify, and your proof is done. This is very important. This side is very important. They are going to ask you questions 4 different times about this entire proof. 4 questions on a 15-question test. Alright, there you have that. You'll see this again on the test review. But this just gives you another way to study.